Is the Earth truly round, or could it be flat, as some insist? Welcome, dear listeners, to a tale of two theories, a debate that has spanned centuries and civilizations. On one side we have the spherical Earth theory, a concept widely accepted today, supported by a wealth of scientific evidence. On the other, the flat Earth theory, a belief that, despite modern science, continues to persist in certain circles. Trace the origins of this argument back to the cradle of civilization. Ancient societies like the Babylonians and Egyptians envisioned the Earth as a flat disk floating in an infinite expanse. Fast forward to today, and you'll find an array of modern flat Earth societies still resolute in their conviction, challenging the dominant narrative of a spherical world. This is no mere academic exercise, but a journey into the heart of how we perceive our world. So strap in, keep an open mind, and prepare to dive into the depths of this fascinating debate. Ever noticed how ships disappear over the horizon, or how the Earth's shadow on the moon during a lunar eclipse is always round? These everyday phenomena, though often overlooked, are crucial pieces of evidence that our planet is indeed round, not flat. Let's start with the so-called sinking ship effect. Picture this: you're standing on a beach watching a ship sail away. As it moves further and further from the shore, it doesn't just shrink in size due to distance. Instead, it appears to sink, starting from the bottom up until finally, only the top of the mast remains visible, and then it too disappears. If Earth were flat, the entire ship would remain visible, only appearing smaller as it sails away. But the fact that the ship seems to sink is a clear indication of the Earth's curvature. Now let's move from the beach to the night sky. During a lunar eclipse, the Earth passes between the sun and the moon, casting a shadow on the moon's surface. And regardless of the moon's position or the time of the eclipse, this shadow is always round. This consistency can only be explained if the Earth is spherical. If it were a flat disk, for instance, we'd see a variety of shadows, oval, straight, or even irregular, depending on the Earth's orientation. But we don't. The shadow is always round, further proving Earth's roundness. These observations, though simple and straightforward, are profound. They are visual affirmations of centuries of scientific consensus. So the next time you're at the beach or gazing at the night sky during a lunar eclipse, remember, what you're witnessing isn't just a beautiful spectacle, it's a testament to our understanding of our home in the vast cosmos. The horizon tells us more than we might think at first glance. Gravity, a force we all depend on, also offers clues about the shape of our planet. Let's delve into the wonders of this invisible yet potent force. Gravity, often described as the glue that holds the universe together, is a force of attraction that exists between any two masses. The greater the mass, the greater the gravitational pull. Our Earth, being a massive body, has a significant gravitational pull, and it's this pull that keeps us grounded. Quite literally. But gravity doesn't just pull us down, it pulls everything towards the center of mass. Imagine holding a ball in your hand. If you drop it, it goes straight down, right? But what if you were to drop it from different points around a giant sphere? Each time, the ball would travel towards the center of that sphere. This is gravity at work, always directing everything towards the heart of the mass. So, what does this mean for the shape of our planet? Well, if gravity pulls everything towards the center, the most efficient shape for an object to be is a sphere. A sphere is the only shape where every point on its surface is an equal distance from its center. This means that gravity affects every point on the Earth uniformly, resulting in a spherical shape. This is why we see round planets, not just here in our solar system, but across the vast reaches of the universe. If a planet were to be, say, a cube, gravity would pull more on the corners and less on the flat sides, causing the planet to eventually reshape itself into a sphere. But let's not forget, Earth is not a perfect sphere. It's an oblate spheroid, slightly squashed at the poles and bulging at the equator due to its rotation. But the important thing to remember is that it's not flat. Gravity doesn't play favorites. It pulls us all toward the center. And in doing so, it helps shape our understanding of the world, confirming that we are indeed living on a round planet. The final frontier, space, provides the clearest evidence of a spherical Earth. It's where we can get an unobstructed, full view of our planet in all its round glory. The evidence from space missions and satellite images is undeniable, and it's there for all to see. Let's take a journey back in time to the early days of space exploration. It was the year 1969 when humans first set foot on the moon during the Apollo 11 mission. The astronauts looked back at Earth from 250,000 miles away, and what did they see? A round blue and white marble hanging in the black void of space. Fast forward a few years to 1972. the last manned mission to the moon, Apollo 17, gifted us with an image that would become one of the most reproduced in human history. Known as the blue marble, this photograph shows a fully illuminated Earth, a vibrant sphere suspended in space, its curvature obvious and beautiful. But it's not just manned space missions that have shown us a spherical Earth. Unmanned probes and satellites have also been sending back images of our planet for decades. Weather satellites in geostationary orbit give us a full view of the Earth every day. These images show the Earth as a circle, with the shadow of night sweeping across the surface, mimicking the rotation of the Earth. Even the International Space Station, orbiting the Earth at an altitude of 250 miles, continuously sends back live video of our planet. The astronauts aboard the ISS look down at the Earth from their cupola window and see a round world. The evidence from space is clear and unambiguous. From the moon landings to the International Space Station, from weather satellites to the Mars rovers, every image and video of Earth from space shows it as a round object. The consensus among scientists and astronauts is unanimous. From space, the shape of our home planet becomes undeniably clear. Despite overwhelming evidence, why do some people still believe the Earth is flat? This question has puzzled many, especially in our era of technological advancement and space exploration. Let's delve into some common flat Earth claims and debunk them with scientific evidence. One prevalent claim is that the horizon appears flat to the naked eye. While this may seem true at ground level, the curvature becomes evident as we ascend. For instance, from an airplane or a mountaintop, the horizon's curve is visible. In fact, the ancient Greeks noticed this phenomenon during lunar eclipses, when the Earth's round shadow is cast onto the moon. Another argument put forth is that water, being a liquid, naturally seeks a flat level, hence large bodies of water should be flat. However, this claim overlooks the role of gravity, which pulls everything, including water, towards the Earth's center, causing it to conform to the planet's spherical shape. Flat Earth proponents also argue that we should be able to see all objects on Earth regardless of distance if Earth was truly round. But atmospheric conditions, our eyes' limitations, and the Earth's curvature obscure distant objects. Ships disappearing hull first over the horizon and buildings appearing top down as we approach them are perfect examples of this curvature at work. Some skeptics question why we don't feel the Earth's spin if it's indeed rotating. The answer lies in the concept of relative motion. We, along with everything else on Earth, are spinning with it, so we don't feel the motion, much like how we don't feel the speed of a moving car when inside it. Lastly, there's the belief that space agencies are part of a grand conspiracy to hide the Earth's true shape. But with thousands of satellites orbiting our planet, capturing images daily, and independent space ventures on the rise, such a conspiracy becomes highly improbable, if not impossible. The key here is critical thinking and scientific literacy. Science is about questioning, but it's also about following the evidence. So, is the Earth round or flat? After exploring the great debate, examining the curvature of the horizon, delving into the science of gravity, viewing evidence from space, and debunking flat Earth claims, it's time to draw our conclusion. We've seen how the horizon's curve is visible to the naked eye, especially from higher altitudes. We've understood the role gravity plays, pulling everything towards the center, creating a spherical shape. We've witnessed the incredible images of our planet from space, showcasing its round form. And we've debunked the flat Earth claims, showing their lack of scientific grounding. In each instance, science has provided us with consistent and irrefutable proofs. It's clear that the evidence doesn't just suggest, but indeed confirms, that our home planet is not a flat disk in space, but a beautiful sphere, spinning on its axis. In the face of evidence, the Earth shows its true shape, a sphere.